So the question at the bottom is a good place to start. If we don't even know what to set as our variables, if we can't figure that part out, the question is a really great place to find that information. How many of each type? So I want to know how many package A. I want to know how many package B. So that's what we need our variables for. What do we want to use for our variable for package A? I hear F and S. Oh, X. Okay. That makes way more sense. I heard F and S. I'm like, those are both very random choices. Not wrong. Totally fine. But they just felt really random, and I was very confused. What about for package B? Totally fair. You can use Y. You could also use A and B. Like, totally fine. That also works. So where in here do we find something that we can write an equation about? Let's find things we have groups of. What do we have more than one of in this sentence or in this paragraph? We got the packages. We definitely know we have more than one of those. Do we have information about like sweatshirts? I was like, yeah, we have 100 sweatshirts, and we know that package B is looking at 3 sweatshirts. Package A has 1 sweatshirt. So if I know package A has 1, package B has 3, and we have a total of 200 available in the warehouse. If we look at sweatshirts, if we sell some number of package A, we usually sell X. We don't know how many it is. But we know package A has only 1 sweatshirt in it. So they get 1 sweatshirt and 1 pair of sweatpants. But all I care about right this time is my sweatshirt. And if I do package B gets 3 sweatshirts. Bouginess. They're sweatshirt obsessed. What could I do for how many sweatshirts we use in package B? How many sweatshirts do they get? 3. Every package B, which we decided to call Y, gets a sweatshirt. Or gets 3 sweatshirts. And how many sweatshirts do we have in total? 200. We've got 200 sweatshirts sitting in the warehouse. Which side do I want to have bigger? The left side or the right side? The 200. I can't go over that. That's how many we have. They're not saying that we're ordering more. We're just trying to get rid of our bulk. They ordered too many last year. I've got 200 extras. Buy them dang on sweatshirts. Then we have the room back. We've got them all stashed in some storage room somewhere, and we need that room back. So if we look at the sweatshirts, we can write an equation like this. Can we follow a similar pattern for anything else? Sweatpants. I got 100 pair of sweatpants. We know package A gets 1. Package B gets 1. So how would we write an inequality for that one, for sweatpants? Less than or equal to our 100 that we have. I heard a couple of different things for our Y piece. I heard X plus chaos less than equal to 100. I'm with you on that one. What's going on with our package B and the sweatpants? How many do they each get? 1. So it's just going to have our 1Y. They only get 1 pair of sweatpants with that. What else do we have in this story? We have the price. Yeah, we've got this. We've got to get rid of some of this stuff. We need to sell at least that many. So if I need to sell at least 20, what does that tell me about the number of package A's that we need to sell? Greater than or equal to 20. How about for our package B? 10, as this guy. So our y needs to be greater than or equal to 10. So we have a lot of pieces in here. We have a lot of constraints is what they are. Do any of these equations have anything to do with the money? No. This is all about how many they can sell. So when we're looking at the money and we're trying to figure out where they're going to get their most bang for their buck, we need to figure out places that will hold for all of these. I need to figure out where this is true. So the easiest way to do that is going to be for us to do like a little graphing thing. But honestly, graphing this many inequalities is super gross. So I'm going to put them on here. I'm going to graph it on Desmos. And I'll show you how to do that. I don't know if it'll let me do it on here. Exit. Boop. I don't get a keyboard. There we go. Desmos. So when we're on Desmos, and if you're... Desmos has been being a jerk lately and freezing on me every now and then. There we go. There's a digital keyboard here. And so what we're going to do is we're going to put all of these inequalities that we just wrote in here. So we can put in our x plus 3y is less than or equal to 200. And it'll graph that for us. Right now, it's just turned my whole screen blue, red because I have a very large graph. We have a whole lot of space here. Boop. So let's see what happens as we add more of our equations. If we have our x plus y less than or equal to 100. That adds another piece in there. And again, we're looking for the place where we have more than one piece being colored. Then we had our x needed to be greater than 20. That is not piece of it. There we go. 20. And that my y needed to be greater than or equal to 10. Ooh. There we go. So we wind up with a graph that looks like this, and this is a mess. There's a lot of stuff going on in here. So when we're looking to figure out where our maximum profit is, where the highest amount of money that we're going to get is, we need to look at where we have truth, where our true region is. So that would be where all of the colors are. So we're looking at this box right here. And I know it's really hard to see on the screen because all of the graphs are a little dark. But inside here is where we have all of the pieces that are being colored. I'm going to make that be a little bit lighter. Whoa. I don't know what I changed there, but I changed something. Oh, I turned the red one off. Ah, no. I do. I don't know what it's doing. It's being weird. It's being weird. So what we're going to do to figure out where our maximum profit is we're going to figure out where our ends of this piece are. So we're going to pick out the ordered pairs for where this box kind of ends. And we're going to look close, and if you do this with a mouse, you can actually click on the pieces, and it'll give us the ordered pairs. So if I come over here and like click on the lines, it'll tell me what that intersection is. So that is going to happen at 20, 10. So if I sell 20 of package A and 10 of package B, is that going to be the most profit we're going to get? I mean, probably not. It's on the very lowest side. It is literally the lowest number I could sell. So what we're going to do is we're going to look at our other 3 points, and we're going to see, oh, this is so hard to do with the mouse sideways and upside down. Technology. We love it. We're going to look at this point over here. So we're going to look at our 90-10. So this guy is 90-10. Oh, that is really hard to read. Let's see if I can find any color that's better. Oh, that one's not bad. There we go. This one's not bad to read. We're going to check out this point up here where they cross, which is 50-50. And we want to check out this point over here, which is 20-60. So we're going to look at these 3 points and we're going to see which one gives us the most profit. And we can do that using the information that we had in the story, because it mentioned, I'm going to just flip this over, I'm going to leave that up here. It mentioned how much they were going to charge us for things, or how much we were charging people. So our package B was for $50 and package A was for $30. So if we want to know which one of these makes the most profit, what can we do? Yeah, put it into an equation. I know that package A, which was what we labeled our X's, was selling for $30. And that package B, which is our Y's, was $50. So if I know we sell, for example, 20 of package A and 60 of package B, how much money will we make? How can I find out? Into what? So if I sell 20 of package A, how much is that going to make us? It'll make us $600, right? Because $20 times 30, or 20 people times $30 a pop, we get $600. If I sell 60 of package B, how much money is that? Yeah, it's 3,000. I just can't hear you because my heater's running over there. So total on this guy, if we sell 20 of package A and 60 of package B, we are going to make $3,600. Try the other two. See what's going to happen for 50-50 and for 90-10. Which one's going to make the most profit? We want to know our profit on this guy, and we want to know our profit on this guy. What do we get for the profit on our 50-50? That makes $4,000. For our 90-10? $3,200. So which set of packages gets us the most money? If I can manage to sell 50 of package A and 50 of package B, that's where we're going to get our most profit. So finding the places where we're substituting pieces in is very much the trickiest part. We got to figure out what we're looking for and where we're looking. So I want to do the one on the next page as well, the Jackson's Party. The next one with the corn squash vegetable dish is so obnoxiously, like, ew. It's decimally, it's gross. It's vegetables. Ew. Let's talk about hot dogs and wings. Yes, dear. Yes. Okay. I was going to say, when I clear this, it's going to clear it. Anybody need to copy this before I clear it? Cool. So we're going to look at Jackson's Party. It's a very similar vibe. It's the next page. So I believe that makes it page 63.
Yes.
63. Just because that last one said 63, so I was assuming this one was also off by a page number. This is literally the last problem in the book for this chapter. Oh snap, look at that. So take a look at this one. We just did some very much like it. See what we can come up with for what's our variable. And maybe work on some inequalities here. What are our constraints? What are our things we got here?
See my phone?
Just double check before I spell that part online. Because I genuinely 100%
That's how you want to get it.
entirely than you could even ask.
450.
There, knocking my bread like,
Let's leave that phone.
fun's gone.
See what we
Bro, everybody gay. Sammy soon.
Oh no, I'm sorry.
Maybe weird, who knows?
What's that?
He's a little dirty joke.
Where's her gun?
Yeah, but why?
That's not all we got.
The big thing about why?
Yeah.
I think so.
Yeah, I
Girl,
did the one on the photograph.
she really wants to like, should I get my belly pierced? I mean, okay, that it's just she doesn't look bad. It was one of the hairstyles like she kept in her head and it didn't look right. But the style she got now, I don't like that on her. But I was trying to keep she just didn't think she was good. Yeah, like I wonder what like her because her sister is a girl and they look alike.
So,
Nina,
I'm with you. Because this is, because she put this is money, right? Money and money. What's our goal for money? You know that?
I feel like Nina maybe Nina look bad.
So what's the cost?
And they look just alike.
Pounds, right?
Yeah,
This
you
is
get what I'm
pounds, pounds,
saying,
money.
yeah.
And this is money.
But I wonder what her
But
reason
it's
is.
money.
But I feel like
It doesn't have a pound. It's not a big thing.
No, Nina should enjoy your life. Graduate, Lisa graduated. No, she should be like us. Yeah, she's an artist. I feel like she did graduate. No, she just be around us already.
Like I knew it was happening, and then my brain decided.
Oh, you see my She's like, yeah. What are you doing? How are you doing the picnic? Oh, I was like, I don't see how you got in the building and know that she do this all talk.
I'm trying to grab these out just in case you want them. Ooh. I love the chat we're having. What is this about? Is it about equations?
I think I gotta work to the front of the menu.
How are we doing on these equations? Yeah. At the very least, let's figure out what our variables are. At the very least, figure out what our variables are. What's up?
I know this is gonna be plus 4.
That works fine. That works fine.
This is gonna be minus because it costs. This is gonna be
greater than no. Something less to something.
So what we got? What are we thinking? Mm-hmm.
I don't know what it actually pleaded.
Okay.
Ruby's got a president's account.
So,
Mm-hmm.
what's up? It's not letting me.
Mm-hmm. Mm-hmm.
That's the other thing I'm Huh?
Because we've got money. We've got money. So money and money. We got one other thing with money? Because we like to usually do groups of 3 things. Is there anything else that has money in it?
Just
Why? Take a video. Take a video with the full lot.
I bet these are 4. They're here 4 fine. Uh-huh. 7 what? What is it?
I got the newest home.
wings.
Mm-hmm. So do we know how many wings we're getting?
They can't hear you. Oh, my AirPods.
We can come up with that one too, right?
5 pounds of hot dog.
He wants at least that many. So he could buy 5. He could buy 7. He could buy 24. Who knows? He's going hot dog crazy. But he's doing the same thing with the wings. He doesn't know what to do. So we're trying to figure out where he's going to go. So we're going to have 2 variables on this one. So we're going to have 2 letters in there. So you're going to have another letter. Okay? You're doing great. Your instincts were right on. Right on. You had all the right pieces. Oop, screen doing weird. All right. So what are our variables? What is it we don't know? How many hot dogs? Whoa, wrong pen. There we go. So our pounds of hot dogs and packages of wings. What are our variables going to be? What do you want to pick? X and Y? Totally fine. Which one did you guys put for X? Hot dogs? Let me see. Trying to figure out what I did. I don't remember. Yeah. So we can absolutely do that. Hot dogs is X and wings is Y. Totally fine. Does wings deal with flight? I don't know. Not much. Chickens don't really fly all that much. How does that help? What can we do with that? How can we write an equation in here? My turn to talk, y'all. What you got, Cameron? Super close, super close. I see exactly what we're thinking. So we know we're gonna buy some wings, and we're gonna buy some hot dogs, and we know we have at most, so it's got to be less than or equal to our $56. But my X is just my pounds of hot dogs. How much does each pound of hot dogs cost? $4. So every pound of hot dogs I buy is going to be $4. Okay. So what do I need to do to my Y to fix this one? 7Y. So this is our money equation. Whenever we are writing equations and we can't really find all our pieces, look for 3 things of the same category. So money, money, money. Could be student, 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 like adult ticket, adult ticket, adult ticket, whatever, like movie theater we're doing, whatever our story problem is. So we did money, money, money. That gave us this kind of, it gives you a kind of standard form equation. What else do we have in here that we need to work with? Because we already dealt with our money, money, money. So we don't need to use them again. What else do we know? At least 5 pounds of hot dogs. How could I write that he needs to buy at least 5 pounds of hot dogs? X is greater than or equal to 5. He's got to have at least 5 pounds of hot dogs. He talked to his friends. I've got 20 people coming that are just obsessed with hot dogs. Weird friends, but okay, it's a choice. What else do we know? Our wings. He needs to have at least 2 packages of wings. So our Y needs to be greater than or equal to 2. So when we're looking to graph these kinds of things, you guys have a graph page there on your page. I'm going to give myself a little white border because I don't have any space to write on the edge. There we go. I'm just coloring my page so I have a little space to write like you guys do. So we picked our hot dogs to be X. So this guy down here, this is our hot dogs. And we picked our Y to be wings. So these are our wings. If we were to graph this by hand, what should we count by on each of these things? Am I going to wind up in the 200s like we were on our sweatpants problem? Probably not. My turn to talk, guys. We've got 5 and 2 right there as kind of starting places. So we could probably count this by ones. Like, honestly, we could probably get away with like 1, 2, 3, 4, 5, etc. Right? 1, 2, 3, 4, 5. 15's over here. 1, 2, 3, 4, 5. Just because I don't feel like numbering everything. As long as I'm counting by a regular amount, 1, 2, 3, 4, 5 units like that, we can skip count totally fine. You do not have to number every single box on your graph. Bless you. How do I draw on a graph that my X has to be greater than or equal to 5? It has to be bigger than 5. More specific, what's it going to look like? Right here, this is where my X is 5. So which side is bigger than 5? To the left or to the right? To the right. So I'm going to use a little highlighter here. If you guys want, I have colored pencils or highlighters that you can use. I'm more than happy to grab them. I actually grabbed the boxes. I'm going to color my highlighter. No, and in fact, since these are equals to, it probably shouldn't be. I was just trying to get you guys to see it. And sometimes when I draw a line, it won't draw the whole thing until I get it all the way to the top. So I would rather you do it as a solid line. So yeah, if you guys want colored pencils.
That might be the same as saying.
Okay.
And you don't have to use colored pencils. I can use like all of their colored pencils. Oh, right behind your computer. Sorry. I know. We're really hard for you to get them. So our X has to be greater than or equal to 5. I'm going to put them out. Oh, here we go. How are we going to do that our Y has to be greater than or equal to 2? What's that going to look like? This one's going to be a horizontal line at 2, which I think if I change this setting, it's going to let me draw it this way. And which way are we going to shade? Are we going to shade up or are we going to shade down? Up. So if all we cared about was having enough food for people, he's got a lot of options here. I'm not going to color the whole thing because that's just a lot. What's up? 5X and 5Y. Only problem is he didn't say he needed to have at least 5 sets of wings. He needed to have at least 2 packages of wings. Oh, for a possible solution? I don't know. We got to get there. We got one more line to do. Because we got to get this guy.
What like I saw the package of wings and I just said what that would cost and subtracted it. Is that possible?
It's like you probably got some valid options. It just might, it's like there could be more options for you. Because he has more than one choice he can make here that just stays in budget and feeds everybody.
Yeah.
All right, so how could I go about graphing this? What the heck can we do?
Oh, no.
All right, my turn to talk still. When we have a standard form equation, to be fair, it's very easy to be distracted in here. And I get that. If we want to graph something like this, where it's in standard form, we could put it into slope-intercept form. We could find x, y intercepts and do it that way. We have a lot of choices when it comes to figuring out how to graph this. I feel like, honestly, the easy way to go is x and y intercepts. Because for this equation, we are ignoring the purple stuff over here. We're ignoring our pink and blue where we care about how many. If he buys no wings, only hot dogs, and spends all of his $56, if he buys no wings, how many hot dogs could he buy? So if he buys no wings, he could buy 14 packs of hot dogs. So the very most number of hot dogs he can buy is 14. If we go the other way, if he buys no hot dogs, just wings, 7y 56, how many packs of wings could he buy? It'll be 8. So we're just finding x and y intercepts here. That is definitely a way you can go about graphing something. There are other options. You could solve this around into slope-intercept form where we subtract our 4x from both sides. We'll then have our minus 4 slope. We would divide both sides by 7. It would give you a very fractiony kind of gross slope. But it would work. But what we're looking for is this line right here, which I highly encourage you to use a ruler for. I cannot because my screen gets super grumpy about it, and if I use the digital line, it only teleports it in, so it doesn't let you see it. So it looks like this. Where would we be shading? Above the green line or below the green line if he needs to spend less than 56? Below, because if he bought no hot dogs and no wings, that is definitely in his budget. So this green portion shows his budget. So what we're looking for in our give some possible examples. I'm going to change the view on the screen here for a second. We're going to look in here at the place where we have everybody. And we're going to pick a couple of points as examples. There we go. Ooh, I don't like that. So what is a point that exists somewhere in here? 5-2 does technically count. 5-2 right here. That one is in the region. So like we're good. He's barely feeding his friends though. What's another one that works? 5-5 would work. Five works. What's another one? Say it louder. 11-2. Barely on the border, but yeah, that one totally works. How about one in the middle? 7-4. Yup, that one would work. 7-4 works. So when they're looking for a couple of examples, that's what we're looking at. We can pick any of these points inside this region where we have everything colored in. Depending on the grocery store, you might be able to pick things in between. I don't know if he's going to order 9.5 pounds of hot dogs and 2.5 pounds of wings. Good luck. But he could try. I don't know what he's going to do with a half a hot dog, but maybe it's a child. But so when they're looking for examples, that's what we're looking for. We're just looking for some of those points that he could buy. So when we're looking at inequalities, it's all about where everybody's true, where all things exist and are true. So when we were looking at our systems of equations where it was equals two lines, we were looking for the point where they cross. Just one. When we're looking at inequalities, we have a lot more wiggle room. It's not just the points where they cross. So that is where we're at for the end of this chapter. Tomorrow, I will get you guys the information on the project, and we will start working on that, and we will work on that for almost a week.